said the tangent has a natural boundary. Here's my 90 pi, 2 pi, whatever, negative pi over 2, negative pi. Now, your tangent says you can't take the tangent at 90 because on your unit circle, if you remember we went through your unit circle, we can't do y over x, we can't divide by a 0. And then the 270 is going to have the same problem. So your tangent had a natural boundary at the pi over 2, at the 3 pi over 2, at the 5 pi over 2, right? So the domain was real except when x was n pi over 2, where n was an odd integer. Remember that? And if you sketch it out, it helps you remember it. Your tangent curve itself goes like this. So its range is all real numbers. Okay? Now, your cotangent, which is this reciprocal, your cotangent curve, kind of similar, but remember, it is now where it's x over y, so it's now wherever y is the 0. So now it happens at the 0 and the 180, because I can't divide by 0. So if these are my 4 quadrants, I can't have at the 0, at the pi, at the 2 pi, because we kind of noticed that the period for pi is different. The period for tangent is pi. It's different than the 2 pi. It has a natural boundary, and cotangent has the same thing. So we notice that the negative pi, at the negative 2 pi, these are where my zeros are. So if I was to look at this and I say 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, my domain for this guy is real except where x is n pi, where n is any integer. And again, my cotangent has a period of 180. It has a natural curve to this. It's an inverse, so it goes the opposite direction. And my range is, again, all real numbers. And it also has a period of pi, which the cotangent probably is a little bit better to see because it does go from 0 to pi. You can see the period right there. The tangent is from negative pi over 2 to positive pi over 2, which is still 90, and 90 is still 180. Is this sounding vaguely familiar? Now, the nice part is, these are the only two that we use. And we have a little trick to this. Which one of those reciprocals, a secant or a cosecant, starts with the same letter as these guys? Cosecant. Cosecant has the same domain and range. And we'll see that in a minute. And secant has the same domain and range as your tangent. We'll see that in a minute. So I shouldn't have wrote over here. Let's see if I can erase this. I can just move this over here. Okay, so let's take a look at your secant. Your secant is a reciprocal of which one? Cosine. And cosine goes 1, 0, 1, negative 1, 0, 1. So I'm just going to make a little cosine curve, a kind of a ghosted cosine curve. 1, 0, negative 1, 0, 1. Okay? Now, where we have problems with the reciprocal is right at these zeros. Because if we take a 0 over 1, and we try to take a reciprocal, we get 1 over 0, which we can't do. So as soon as you make your basic curve, your asymptotes fall right where your zeros are. So if this is pi over 2, and this is 3 pi over 2, and the next one would be 5 pi over 2, aren't we all real except n pi over 2 where n is an odd integer? So our domain says real except n pi over 2 where n is an odd integer. Good so far?
So basically,
They're at the zeros because it's the zero that you can't invert. Because 0 by itself, you have to put it over 1. So 1 over 0, you can't divide by 0. So, and wasn't it the zeros over here that we had to find whenever our divisor was going to be a 0? Okay, and the last one, the cosecant, if I can squeeze it in here, is the reciprocal of sine. Now, sine, if we can graph this, just ghost this, looks like this. Oops, sorry. Now, our problems again are the zeros. Wherever it falls to the zeros. At 0, at pi, at 2 pi. So again, it follows what your cotangent did. Real, except when x is equal to n pi, where n is any integer. Now, I didn't draw these off here. I forgot to just draw this part, but just so that you get your domain. So we draw our curves within those little boundaries, within those asymptotes. Your range on your cosecant curves, your cosecant and your secant, are the opposite of your sine and your cosine. So both of these ranges are going to go from negative infinity and stop at negative 1, and then, God bless you, then restart at 1 to infinity. It's kind of crammed in there, but do we get the general little picture here?
the tangent was kind of confusing me, but
This,
you know like how to put the curve on it when like if you draw your original curve, it's just the opposite, right? It's flipped.
yes. Well, it's for the sine and the cosine. Mark off your zeros. Those are where your asymptotes are. So as soon as you mark off your zeros like this gives you a natural boundary to make your curve. Use the bumps of the curve because you're not going to go in through here. You're not in there. You're not doing any of your sine curve. You're doing everything else but your sine curve. So the asymptotes are always at your zeros. They make your kind of your boundary. Just to make, it's like a little parabola within that boundary. Okay? So let's take a look at your homework. Maybe we can remember this back now. All right. So the first one we said, did we? Oh, well, I don't know if we did any of these together, but we'll do the math. The first one we said, this is really like saying 1/2 x. There's really no, you can do them without graphing, but I always, there's really not a better way than graphing your original and then graphing it off of that. I think that's probably the best way. So if you start like this, and you're going to graph this first with your cosine curve. I'm just going to say 1/2 x. Graph your cosine curve with 1/2. What does this 1/2 tell me?
It's half a 1 and 2 pi.
It's half a 1 and 2 pi. So my period is then going to be 4 pi. So the easiest way to start that is like this. I'm at 1, the amplitude doesn't change, so I'm here, halfway through I'm here, then I'm here. And just go the opposite way. So you can almost see your whole curve in 4 pi, right? Now, what's going to give you trouble again are your zeros. Because when you take 0 over 1 and you put 1 over 0, can't do it. This is going to be where it's coming from. And again, you're going to see it come like this. It's going to stay within that asymptote. It's the asymptote you care about. This was at 0. This is now at pi. Okay, this is at 2 pi. I'm still way down here. Where do you think my other problem is? I'm at 1 pi. 2 pi is okay. Where am I going to come back up here? At what? At 3 pi. So I'm looking at 1 pi. I'm looking at 3 pi. So I'm looking at x is equal to n pi, where n is an odd integer. Okay. Did my range change on this guy at all? No, I'm still good. I'm still negative infinity to negative 1 and 1 to infinity. Now, an easy way to do this, a little even easier, you have to graph this, yes, but an easier way to get your domain and your range are come back over here and get your original secant curve. Your original secant is just like the tangent, where n is any odd integer and pi over 2 where n is any odd. See, this is x equals, well, you now have x over 2, or 1/2 x, equal to that. So just substitute that x for x over 2 and solve for x. They both have the same denominator, so the denominators come out, and we get x is equal to n pi, and you keep the same exact qualifier. So isn't this exactly what we found when we put our asymptotes there? We found exactly that when we put our asymptotes there. So real, except x is equal to n pi, where n is any odd integer. If you just take your original one and set it equal to what in place of x, whatever x is. If it's 4x, set it equal to 4x, divide by 4. If it's 1/2 x, set it equal to 1/2 x, multiply it by 2. You just have to solve for x. We okay with this? Yeah? Stop me if you're not, because I know it's been a week since we did this. It's probably been a week since you did your homework, right? I don't blame you. Who knew we were off all this time? Okay, now, this guy, where's our transformation in this one? What was it originally? What's our parent graph? Tan x. Tan x. What's the domain for tan x? Well, think about where your things go. Where can't you take a tangent? At 90, pi over 2. At the bottom one, 3 pi over 2. So how would you set that up? 1 pi over 2, 3 pi over 2, 5 pi over 2, n pi over 2, where n is odd. Any odd, you have to say integer. Because any number could mean 1.2, 1.6, negative 2, negative 2.1. So we have to say n is any odd integer. Now, our transformation is right here. If it helps, look at it this way. You did half the tangent curve in pi. Remember, the period for tangent is pi. Now you did half the curve in pi. Because this is its period. So how long is it going to take you to make a complete tangent curve? If you did half of it in pi, and if you need another pi, so your complete period now is going to be what? 2 pi. So your tangent curve went off the middle. Originally it was at the 90s, wasn't it? But think about this. I expanded this twice the size. I stretched this twice the size, right? I'm stretching this. Didn't my period go from 1 pi to 2 pi? Didn't I stretch it? Now, just think about this because it actually makes sense. If your original tangent asymptote was at, let's do degrees, at 90, and I double that, where's my asymptote going to be? 180. So if my original was at pi over 2, and I doubled it, I multiplied it by 2, I will be at pi. So here's my asymptotes now. At pi, at the negative pi. So at 0, at pi, at where else? 2 pi. Not at 2 pi. I've got to go pi. I got to go 2 pi now. At 3 pi. I don't have enough space here, but yes, at 3 pi. So I'm at 1 pi. I'm at 3 pi. Do you see the odd integer going on here? Because this makes my complete curve. This is where I got stretched out here. I used to be right in here. Now I said stretch this out. Now I'm in here.
And you knew that because why?
Because of this 1/2. It said 1/2 of the tangent curve in, remember the period for tangent is only pi. So if I get 1/2 of the tangent curve in pi, it's kind of like a cosine curve. If I say cosine 1/2, you're giving me half of the curve in 2 pi, because that's its period, and then another 2 pi. But the tangent's period is only pi. So if I doubled it, I am now 2 pi, right? So if I'm still at the 0, isn't the tangent of 0 still 0? I didn't change that. So here's where my stretch came in, right here. So it kind of makes sense if you think about it, doesn't it? So now, another way to do this is to take this, take your original, here's my original tan, and instead of the x, I am now x over 2. Again, common denominators are the same. So bring down your original qualifier. Isn't this exactly what we found when we drew our graph out? Yeah, it all makes sense, doesn't it? It all kind of makes sense. And when you change a frequency, it has an opposite effect. A 1/2 is actually going to stretch it out. Why? Because with your period, if it used to be pi, it now is twice the size of it, 2 pi. So it stretched out your period by a factor of 2, not 1/2. An amplitude changes you by 1/2 or doubles it by 2, but a frequency change has the opposite effect.
So frequency is opposite.
For the 1/2, yeah. Now for the next one where the frequency is 2, that means I need 2 curves of that in its period. And the period for tangent is pi. I want you to not panic over this. I want you to think it out. I want you to be able to think and say, what is this going to do? So watch what this guy's going to do. Let's see if we can think this out. Try not to look at my writing. Try to look at just this. We have this. Now, my frequency is 2. That means to me what in words? 2, in 2 cycles, in, what is the cycle for tangent? Good. 2 cycles in pi. Therefore, how long to complete 1 cycle? Half of pi, which is what? 90. So my period is my period going to be pi over 2? Aren't I going to have a lot more of those curves inside? So now let's just think this out again. Here's my 4 quadrants. Okay, now watch. I used to be at the 90s, and this would give me a period of pi. But I need to make more of these guys. So I need to go twice as many. So where's my asymptotes going to go?
In the middle.
Oh, in the middle. Good. And what is half of pi over 2? Sorry, half of pi over 2. What's half of 90? Pi over 4. So here's my asymptotes now. See my asymptotes? So look where they're coming. They're coming in between. Now doesn't that make sense to you though? If before I had to go half the time and I had to stretch it out, I doubled it. Now I'm doubling them, I've got to go half the time. So look where my curve is now. And now isn't this period of pi over 2 of 90? And didn't we say I had to do 2 in pi? So 1 in pi over 2? So now, from here to the next one, I got to make a period of pi over 2 again. So I'm going to do this again and put another one here and go like this. And here's my asymptotes. Now watch. This is 1 pi over 4. This is 2 pi over 4. This is 3 pi over 4. So I've got a pi over 4. I've got a 3 pi over 4. Where's my problem? Where's my exceptions? At n pi over 4, where n is what? Odd integer. So let's see if that works according to the way we can do this. We take our original domain for tangent. We replace this x with the 2x. We cross multiply. So we get 4x is equal to n pi. We divide by 4. Well, look at that. X is equal to n pi over 4, and we keep the same qualifier, where n is any odd integer. But I want it to make sense to you when you look at the graph. Now, the tangent's a little harder to get because tangent is not a continuous curve, and its period is not 2 pi. Its period is pi. But you can kind of see that if you visualize your circle, where's your problem? At 90, whoops, 180 degrees away, right? Or at the 0, whoops, 180 degrees away. So your period is half of it. Before it repeats. You're going to do more of these. I have another worksheet to follow up on this just because this was a big space here. Okay? Are we okay with these? Okay. Now I kind of threw a little bit more at you. This guy, how did this change? What changed this one from your parent graph? Just the amplitude. Did my period change at all? No. So a good way to start is with what curve? What is my reciprocal of cosecant? Sine. So my sine usually went from 0 to 1 to 0 to negative 1 to 0, but my amplitude amped it up, bumped it up by a factor of 2. 0, 2, 0, negative 2, 0. So I'm just going to start my sine curve. I'm going to ghost my sine curve. 0, 2, 0, negative 2, 0. Again, go the opposite way. Negative 2, 0, 2, 0. Okay? Nothing else changed but my amplitude. At the zeros again is where my problem is. At the 0, at the 1 pi, at the 2 pi. So my domain stays the same exact as my original. Real except when x is equal to n pi, where n is any integer. But my range changed on this one, right? So what's my new range? I always forget to draw these. Negative infinity to?
Negative 2.
Good.
And 2 to infinity.
And 2 to infinity. Good. I think that was kind of a nice one, right? We just saw a little amplitude change. Everybody okay with this? Okay. This one's a little bit strange, and I would like you to understand where this is coming from, but I wouldn't give this to you on a test, but I still want you to understand where this period is coming from. Here's my cotangent. I didn't give you this?
No.
Oh, okay. I guess I took them out. I didn't give you this one either then, right?
No. 7.
I give you this?
Yeah.
Okay. I guess you got off the hook. But we'll go back to one of those. Maybe tomorrow we'll go back to it. Because sometimes your period, when we say your period is 2 pi, that's in radians, right? If you multiply 2 by pi, we get 6.28, which is what your calculator does. So whenever we get a period with an n value in it, it's just a radian measure. So instead of starting your graph as pi over 2 pi, we're going to do it 1, 2, 3, 4, 5, 6, and graph it that way. But because it's still in radians. So that I don't confuse you, better that I didn't do it. So this negative just starts us off with a reflection. Your domain is not changed, and neither is your range. Your range and your domain will not change on this. It will just start in the opposite direction. So instead of my sign going up, my sign is going to go down. Did it change my asymptotes at all? No. My asymptotes are still where they were. At the 0, at the 1 pi, at the 2 pi, at the n pi, where n is any integer. And my range didn't change either. My range is still the same because my amplitude didn't change. Remember, your amplitude is still 1. Your reflection, the negative, is a reflection, but the amplitude is never negative. The amplitude is always the distance from the crest to the top, from the resting point, or midline, to the top of the wave. It is always measured in a positive. What that negative does is just a reflection. Good?
Okay.
Okay, so we really didn't have any major changes because the asymptotes didn't shift. There's no shift here. Nothing moved over. And this was probably your last one? 9 and 8 and 9? Okay. Now, this guy said, give me 1/2 x. So this is off your sine curve. So start like this. Start with that. What is the frequency of 1/2 going to do to your sine curve? Stretch it out, right? By a factor of what? 2. So everything's going to be doubled over there. So now, my sine curve, my period, is going to be what? Instead of 2 pi, my period for sine and cosine is 2 pi. Sure, now my period is going to be 4 pi. Don't I need twice the space to complete this? Mm-hmm. So here I am at the 0. Then halfway through, I have to skip over this because I'm doubling. Double this. Then I'm way down here and way up here. So instead I'm going to come back down here and back over here. Didn't I take 4 pi to complete this cycle? Where am I? I missed. Didn't I take 4 pi to complete that? Mm-hmm. Right? Now, all I care about with my reciprocal, which parts are going to give me trouble? Where's my asymptotes going to fall? At the zeros. So here's a 0. Here's a 0. Here's a 0. So there's going to be my cosecant. Did my range change at all? No, range stays the same. But my domain changed. Now, if we look at this, it's at the 0. It's at the 2 pi. It's at the negative 2 pi. What would be another one? Because my period is going to be what? Mm-hmm. These are where my zeros are. It's going to be at the 4 pi. It's going to be at the 6 pi. It's going to be at all the even numbers, right? But we never really had one that said even. We either had one that said every integer or every odd integer, right? So we can do away with the odd integer because that's not happening. So if we wanted to make this something pi where n is any integer, I can't just put n here, right? Because that would give me 1, 2, 3, 4. What will I put here to make it give me all the even ones? 2. Just multiply this by 2. I only have 2 qualifiers. N is any odd integer, n is any integer. Now, if you gave me n pi, any even integer, it's not wrong. It's not wrong because that's what it is. But I kind of want you to stick to the original. Because if we looked at your original domain for your cosecant curve, here's my x. I'm going to take that x and replace it. So I'm going to multiply both sides by 2, and I get this. I go back to my original qualifier. I get the same thing that we did here. So real, except x is 2n pi, where n is any integer. And my range stayed the same. We didn't affect the range. I find it much easier if you graph off the original one first. Even if there's only 2 that you really have to remember. Real except x equals n pi over 2, n is odd. Or real except x equals n pi, n is any integer. There's the only 2 you have to remember. So if you go back and you set that to whatever this guy happens to be, you will find your domains. Your domain restrictions are your asymptotes. But those are the pieces we can't use, right? Those are the pieces we're not allowed to use. Let's try one more. Are we good for one more? Okay, so now, cotangent, again, is a little different. What's the period for your cotangent? Pi. So your period for cotangent is already pi. Now, this is saying I want half of the curve in that period. So now what's my new period going to be? If I want half of the period in pi, how long is it going to take me to make a complete one? 2 pi. Right? Same as we just did with the tangent one before. Okay? So now, here's my cotangent. Okay, it used to be at 0, and then it used to be at pi, remember? But the 0 is not going to change, right? So it's going to be at 0, and now how long is this going to be? 2 pi. So here's my 2 pi. So what's halfway between this? Pi. So my curve is going to go like this. Halfway between these asymptotes. I just extended that period, didn't I? So the same thing here. I'm going to come to my negative 2 pi. Pi is going to be the middle. And again, it goes like this. Now again, look where you are. You're at the 0, you're at the 2 pi, you're at the negative 2 pi, you're at the 4 pi. These are the even ones. So since we needed to say n is any odd, not happening. And is any integer? Well, we can play with that one a little bit. But we need them to be even. So we're going to say real except 2n pi, where n is any integer. And again, this is the rule you want to use. You want to take the original, you want to replace that x with the x over 2. And then you come up with your new domain. And your range doesn't change on a cotangent. Even if you change an amplitude, your range doesn't change. Does it make sense? A lot of blank faces, a lot of sleepy faces.